Hello everyone, my name is Alicia Greenman, and today I will be discussing the analytical and experimental study of solar radiation for water desalination systems. I'll be presenting this on behalf of everyone who worked on this project, including Lily Sorosi, Zachary Weber, Antonio Soria Verdugo, and our advisor, Dr. Carbajal. So there are many areas around the world that do not have access to clean drinking water, and many of the processes that we have in place today for water desalination often require a high amount of electrical power. So by using solar radiation, we can then reduce the energy consumption as well as hopefully increasing the amount of clean drinking water readily available. So the main objective of our project that we're going to be focusing on today is developing an analytical and experimental analysis to investigate the performance of the system, as well as seeing how viable it really is. So to start, we did a thermodynamic model to estimate the amount of energy required to boil water in the system. And so by using the first law of thermodynamics, we found that the energy required is directly proportional to the volumetric flow rate and quality of the water in the system. So as the volumetric flow rate and the quality increase, the power required will also increase. This will help us give us an idea of how much power we will need when actually using our system. As for the experiments, we used a saline solution of 35 parts per thousand as the initial solution. It was boiled to extract the water vapor, and that passed through a condenser at temperatures of 25 degrees Celsius and 15 degrees Celsius. And then we collected the water after it went through the condenser, and we used a saltwater tester to test the salinity after the entire process. And these results can be seen in figure 4 and 5. So comparing the 25 degrees Celsius case to the 15 degrees Celsius case, the overall process time, meaning that the water was boiled, went through the condenser, and collected again, took less time than the 15-degree Celsius case, as well as the max salinity of the 25-degree case is less than the 15-degree case. And we can also determine the overall efficiency of the process by comparing the mass flow rates in and out of the condenser, which can be seen in figure 6. Now in figure 6, there are some dips and valleys in the graph. This is believed to have happened because the water being boiled is transferred to another container to actually measure it. And so there may have been just some loss of water during that process. And as for the salinity in figures 4 and 5, the salinity does increase over time. This may have been because there may have gotten salt into the condenser, and so that just may have affected the actual salinity of the water that is outputted from the condenser. So for further testing, we are going to use stricter contamination procedures for the condenser to hopefully understand if this increase in salinity is a trend that we will be seeing over and over again, or if it's just a one-time occurrence because of the contamination in our condenser. Well, thank you for your time, and I hope you have a great day.